So we're in OpenStax Statistics, Chapter 10, and we're going to be talking about testing differences for proportions and medications. You can always access the OpenStax book. You could just look in the description of this video for a link, and you can go to divideandconquermath.com and go to the OpenStax Statistics section to get a copy of this Excel workbook. So two types of medication for hives are being tested to determine if there is a difference in the proportions of adult patient reactions. 20 out of a random sample of 200 adults given medication A still had hives 30 minutes after taking the medication, and 12 out of another random sample of 200 adults given medication B still had hives 30 minutes after taking the medication. So we're going to test at a 1% level of significance. So now we're moving into proportions, and so we need slightly different formulas for this. So I have a reference here of the formulas that we're going to need to do this. And additionally, it's always helpful to know what your hypotheses are. So in this case, we're being asked to determine proportions if there's a difference between them. And so if that's all we're being asked to is whether there's a difference or not, that's going to be a two-tailed test. So the first thing that we're going to want to do is, and I guess maybe I called this group 1 and group 2. I guess I should have called it group A. Maybe I'll just switch it. Group A and group B. Okay, so the next thing that we're going to want to do here, right, is we're going to want to just organize our information. So I just switched it all to A and B just to make it more obvious. So I've got group A and group B. So I've got my N and I've got my X for these. And that's all I need to really get this particular party started. So let's see. From group A, it was 20 out of 200 that still had hives, and from group B, it was 12 out of 200 that still had hives. Okay, so in this case, now what I need to do is I need to just really go through and calculate kind of all of these formulas here. So you're going to have your proportion for group A, so I'm going to call that P prime sub A. So I'm going to just take that as 20 out of 200. And I'm going to have my P prime for group B. So that's going to be my 12 out of 100. And then you also need to compute a pooled proportion. So I'm going to call this my pooled P. So that's referred to as P sub C, and we know it's a pooled proportion. And that is found by taking the two numerators for each proportion and adding them and dividing that by the two denominators. So just make sure when you do this that you do have parentheses around the top and on the bottom, or you are going to get an order of operations problem with this. You do have to put parentheses around the top and the bottom. Okay, so those are now all going to go into the next set of calculations. So we're going to compute the standard deviation, and notice that this standard deviation is what's going to be the denominator ultimately for our test statistic. So I'm going to have my standard deviation, so I'm going to take the square root of, so I need to take that pooled P sub C times 1 minus that pooled P sub C, and then I'm going to have 1 over n from the first group plus 1 over n from the second group, and I take the square root of all that. So my standard deviation is 0.027129, so make sure you got that as well. And then I can compute my test statistic. Now when I compute my test statistic, I'm going to take my P prime from the first group minus the P prime from the second group. And then when you're subtracting off this P sub A minus P sub B, this is a hypothesized difference. So generally this is 0 unless you're told otherwise. Once again, make sure that you have parentheses around the entire numerator of this, and then you can just divide all of that by the standard deviation. So here's my test statistic. Okay, and so now, since we're talking about proportions, proportions are always using the standard normal distribution. So if I just wanted to draw what the p-value of this looks like, so my p-value, I'm going to have this 1.474 somewhere over here. So I'm trying to compute this area here. But remember, in this case, what we have is we have a two-tailed test. So I also need to find the same area on the other side of the distribution. So whatever my p-value is for the test statistic that I just computed, I need to ultimately multiply that by 2. Okay, so let's go ahead now and let's compute our p-value. So I'm going to use my norm.s.dist function. So this test statistic falls on the right side, so I'm just going to want to make sure that I take 1 minus that. Oops, and I didn't put in enough. There we go. Okay, so here's my p-value. Maybe I'll just say p-value on one side. And then let's see my p-value from two sides. So now I'll take that value and I'll multiply it by 2. Okay, so here's my p-value, which is a huge p-value. So in this case, we cannot reject the alternative hypothesis because that is greater than our 1% level of significance, so we do not reject. So there's not enough evidence to suggest that there is any difference between these two medications.